Alright, this is lesson 2.5 part 2. You're going to be able to solve more complex inequalities, and we're going to do that using some graphing methods with a little bit of algebra. Remember that last time in part 1 we looked at and reviewed how to solve a compound inequality algebraically, and sometimes you do that by creating two separate inequalities when you have a compound inequality that has variables in more than one location. And then sometimes you can do that by applying the addition and subtraction and multiplication and division rules to the whole inequality and solve it all at once, like we did in the second example. In this lesson, we're going to look at some even more complex inequalities that we're going to first apply a little bit of algebra, and then we're going to use the graphing calculator tool that I showed you in a previous lesson to figure out where this inequality is satisfied. So let's get started. You might recall that in a previous lesson we discussed how you can use graphs to find solutions by either graphing both sides of an equation, or you can set this equation or inequality equal to 0. And that's what I'm going to do in this problem. On the left hand side I have x to the 4th plus 10x to the 3rd plus 21x squared. And on the right hand side I have 40x plus 80. I'm going to go ahead and subtract 40x and subtract 80 from both sides. And that will give me a new inequality with all of that stuff. X to the 4th plus 10x to the 3rd plus 21x squared minus 40x minus 80 is greater than 0. Now, if you'd like to try to solve that algebraically, go right ahead. But what I'm going to do now is take this whole left-hand side and just make that a function that I'm going to plug into a graphing calculator, find the solutions, and then determine where it satisfies this inequality. And this inequality says that all this stuff has to be greater than 0. So let's take a look at the GeoGebra graphing calculator. Alright, here's the GeoGebra graphing calculator, and if you don't remember, you can get to that just by going to geogebra.org. It takes you here. You're going to select the graphing calculator right here in the middle, which takes you to this page. Now I'll put that link in your assignment so you can access it quickly, but if you remember geogebra.org, that'll make it easy for you to get there in the future. So I'm going to enter the function f of, oops, I'm in the wrong spot. I'm going to click down in here where it says plus f parentheses x equals. I'm going to generate a function, and that function is x raised to the 4th power. Now to raise to the 4th power, you're going to use that key on your keyboard above the number 6. It's called the caret key. That'll give you the 4th power, arrow to the right, and I'm going to add 10x raised to the 3rd power. Again, it's the caret key to the 3rd power, arrow to the right to get out of the exponent, plus 21x to the 2nd, arrow to the right. Now, I keep saying arrow to the right, and I'm hoping you understand that on the keyboard you're going to push the right arrow button. That's going to take you in and out of the exponent. If you look at the second exponent where my cursor is, then it's minus 40x and minus 80. And there's the graph. Hit enter. Now, if I zoom out by selecting the minus, zoom out a little bit, you can see that that graph isn't just a parabola, but it makes this weird W shape. What you also notice is that this weird W shape only crosses the x-axis in 2 places. So I'm going to zoom back into where those 2 places are. Now sometimes you can look and find the exact answer, but in this case these are not whole numbers. So we're going to find out what they are by using the calculator and having it do the work for us. So remember that when a graph crosses the x-axis, the point where it crosses is also called the root or the solution. So the input or the command for GeoGebra finding the place where it crosses the x-axis is just root. So I'm going to type in root. And notice it kind of gives you hints as to how you're supposed to enter that, but I'm just going to hit parentheses. And what I'm trying to find the root for is this function f of x. So I'm going to type in f parentheses x parentheses and then hit enter. And what it gives me are the 2 points A and B where this graph crosses the x-axis. These are the two roots. It crosses at negative 5295, 256, and so on. And it also crosses at 1.89. Now, let's go back for a second. This inequality that we set greater than 0 is this whole function which we just graphed. So what we want to know is, when is this function greater than 0? And greater than 0 means it's above the x-axis. So, going back to our graph and our solutions, we know that the graph is above the x-axis or above 0 when x is at this point or less and at this point or greater. And in fact, because our original inequality is just greater than, it's not going to include these points. So how do I write my answer? The answer to this inequality is that this inequality is satisfied when x is less than negative 1 point. It was 1.5295, so we're going to round to that, or when x is greater than 1.89. And those solutions came from the graph, figuring out what the roots were, and then figuring out where the graph, when the graph is above 0 or above the x-axis. All right, let's look at another example. Now in this example, 2x squared plus 3x minus 4, your textbook that I've been using actually asks you to use the quadratic function. That is negative b plus or minus the square root of b squared minus 4ac over 2a to find the solutions and then use your graph. But what I'd like you to do is just use the graph with the GeoGebra tool and find the solutions that way. So let's go back to the graphing calculator. Alright, go back to the graphing calculator. We can delete what's in there by clicking on the 3 dots and deleting. And then you enter a new function. We're going to enter f of x equals 2x, use the caret key, squared, arrow to the right, plus 3x minus 4. Enter. Now, this is a quadratic function, so it creates a parabola, but if you don't believe me, you can zoom out really far and see if you can find anything. Nope, it's a parabola. So we're going to zoom back in using the zoom tool. Now, remember, the original inequality was set less than or equal to 0. In other words, we want to know where this function is less than or equal to 0, or this time below the x-axis. So you can see by looking at this graph that this parabola is below the x-axis in this part of the graph. And in this case, it's between this number and this number, and because it's or equal to, it includes these points. But first we have to know what these 2 points are. So again, we're going to go over, and we're going to type in root, parentheses, f of x, and hit enter. And again, it gives us the 2 points A and B where it crosses the x-axis, negative 2.35 and 0.850. So, to write an inequality we're going to say that the solutions to this inequality are all the x values that are between either greater than the left-hand point or less than the right-hand point. And notice I have the or equal to because that includes. And if you look back at the graph, the points where it crosses the x-axis were negative 2.35 and 0.85. I hope that's correct, but I'm pretty close. So that's the solution to that inequality by using the graphing or the graphing calculator. Alright, let's look at one last example. And this one is almost done for you. Now remember, when you're graphing, or excuse me, when you're solving an equation, if it's factored out for you like this is just a made-up example, then you know the solutions to this would be what it would be if x minus 5 equals 0, and what it would be if x plus 1 equals 0. That would give you x equals 5 and x equals negative 1. Same is true with this inequality. It's almost already done for you. You know that the roots, or the points where the graph crosses the x-axis, will be at negative 5 and positive 2 and positive 8. But what you don't know is what it looks like, whether it looks like this, whether it looks like this. So you're still going to have to graph it, but you at least have a head start or an idea about where this graph is going to line up. So I'm going to take just exactly what I see and enter it into the graphing calculator. So once again, I'm going to click the three dots and delete what's there. I'm going to enter in a new function f of x, parentheses x, equals, and then in the first set of parentheses, x plus 5. In the next set of parentheses, x minus 2, and that's raised to the 6th power. And then the last set of parentheses is x minus 8. Okay, notice this graph crosses the x-axis at negative 5, at positive 2, and at positive 8. Now what I need to know is, where is that graph less than or equal to 0? Where is it below or touching the x-axis? And I can see from the graph that from here at negative 5, it's below, and it stays below all the way until it gets to 2, where it touches the x-axis, but that's also equal to. So I haven't gone above yet, so from negative 5 to 2, and then all the way up to 8, and that goes above. So the inequality that I'm going to write for my solution would be all the numbers that are between negative 5 and positive 8. So the answer to this inequality is that x is between, that means it's greater than or equal to negative 5, all the way up to equal to 8. Remember the graph looked like this. Between negative 5 and positive 8, these values are all below the x-axis. That's my solution. Okay, I'm going to stop there and let you practice that with a few problems for your assignment.